what VoxVoi is, so I will quickly try to go over it. There is, unfortunately, that's a management presentation, so you're gonna get, a lot of PowerPoint slides. I don't have any code. Eve has code on PowerPoint slides, and and Martin doesn't have any code on his slides at all. So basically, it's a lot of blah blah. But yeah, that's what architecture is. We're trying to give you visualizations on how what we're trying to give you some visualizations about what we're trying to talk about. But yeah, so VoxVoi is basically a contact center in the cloud. So it goes from you can just accept calls on specific numbers, and then you can do a lot of typical stuff that you do with call centers, but we have some unique features. And some of them is data correlation from web-initiated calls. So for example, when you're starting a call through a web page, so a browser call that ends up into a real phone call, then we do data correlation with that. So basically we pass to whatever system you want, whatever kind of information you want from the website to that system. And we also give that information to a dashboard that you have. So you have a dashboard in front of you, you can see the incoming call with all the data that you requested to be passed to the system, or the default data that we have, which is, for example, from which page you came and all those things. Another unique thing is that we do dynamic routing on the calls, so we can query web services, databases, any kind of resource that is provided by .NET. So we have an abstraction on top of the providers for .NET, so you can basically query whatever you want. And then we parse that information, and based on that information, we route the call to specific agents, specific queues, specific conferences, and so on. Out of the box two-factor authentication, so you just hook up to our system and you're saying if it's successful, then call this URL. If it's not successful, then call that URL. Advanced reporting, so we don't just give you the average numbers, okay, average weighting and average that and average that. We go a bit further than that in relation with the data correlation feature. We support a lot of languages for text-to-speech and speech recognition. So we detect voice, but we also make text voice. And we support a lot of languages on that. And by launch, we should have at least 10 languages supported in the system. And we should have the same thing for the advanced speech recognition. So we should be able to understand what they're saying, not the very complex stuff, but more command stuff. Or in case we want to do transcription, so if they leave a recorded message and we want to make that text and send it to you through an email along with the recorded message, then we can do that as well. Another benefit is that you can have remote agents, so you don't really need people sitting in a room or whatever. All they need is an internet connection in a browser. They don't even need a physical device to start accepting calls. So you can basically outsource that to other companies, or even hire people from other regions, so you don't have night shifts, or you cover other regions as well, depending on the time zones or whatever have you. And we have integration with a couple of CRM and ticketing systems. Zendesk, Salesforce, and Dynamics CRM is going to be the first ones, but we're going to try to expand them. Why should you come to VoxVoi? In case you need enterprise-grade contact center features, right? So not the typical contact center stuff. Everybody does queues, everybody does conferences, everybody does those things, right? But the benefit here is that you can create your own extensions on top of the platform and do whatever you want. It's software, right? It has nothing to do with hardware. It's not Asterisk. It's not free suites. It has nothing to do with SIP, right? It's not that thing. It's just software that does all that stuff. The actual implementation of how we do it, you shouldn't care anyway, right? It's really cost effective in terms of you don't have to buy hardware, you don't have to buy special software and all those things. We're trying to constantly expand and improve. It's really easy to set up. You just get a number, build a menu, and basically after that you start accepting calls. And I already talked about customizations per customer. You can analyze the call history easily, so you can just do that online. And we can give you better call agent control, so work shifts, from where they work, how long they worked there, if they're meeting your SLAs and stuff like that. So I think every one of us, they go a bit how we came up with the idea and how we proceeded with the idea and actually doing the implementation. Actually, I know Martin does. I don't know about you, but yeah, because I was looking at his presentation. So why, when, and how? We started because I started because I thought there is a market gap into that part of the call centers. There isn't anything similar to it except two companies, but those two companies, they refer to the high enterprise, expensive field where Cisco and Voice9 and all those guys are, right? So they're not referring up to there, they're only referring there, which costs a lot of money. And if you go to Cisco to set up whatever solution they have, when you get the invoice, you're not happy. So, yes. We wanted to be different and a bit of hip. And hip meaning that being modern, being up to date, and following all the technologies that are out there. And the idea was perceived somewhere around last August. I was on vacation on Corfu. And literally, it's not a joke. That's where I just came up with the idea of creating something like that, because I was at the hotel that was having problems with a call center at that point. And I just thought, I don't know exactly how it came to my mind, but that's how it happened. So as soon as I was back from vacation, I started working on it. And I gave the first public talk about it, and I've shown a small prototype of how it works and what it does in November 2012 on Windows Azure Conf. So it was about 5 6 years. So currently, except that we use Twilio for our telecommunication needs. So Twilio is the underlying platform that provides all the numbers and all the a lot of functionality that we give as well. And we're based on a couple of technologies. ASP.NET MVC4, we use both the Razor engine for the public views and the public website. We also have Web API for the internal use, but also for the external developer API that people can hook up on the platform. Knockout, SignalR. In case you don't know our engine, I will let you know what that is. And this is something, we had a small discussion with Martin. This is something unique, so I thought, he said include it, and I like the idea, so I included it as well. What? It's the truth. So, the architecture. Although it's almost impossible, I wanted to nail it from the beginning. But it is impossible, right? It's not. It is impossible because you can think about it as much as you want. You can design it as much as you want. When you're actually coming to the real implementations, things go a bit different, right? And the reason is that you're working on top of a lot of assumptions. This is something new. This is not what you do every day, right? If you get me to design an architecture for a normal .NET application, most likely I will get it right? So there will be changes or whatever, but not major stuff or whatever. But when you're talking about something which is completely new, it's not as easy as it sounds. I thought it was easy. It's not easy. So at the beginning I failed, and the reason I failed is that I wasn't abstract enough. So I was really tied to Twilio, which is not what I wanted. I wanted to be abstract enough to be able to plug in multiple other providers as well. So I refactored that part. I said, take all that stuff out and put it there. Then I failed again because I realized that was not the only problem. I was not abstract enough to provide customization. So we're talking about multi-tenant environments, and I needed to provide customizations to customers. Not everybody wants the same stuff, right? And when it comes to specialized solutions like quitting CRM systems and stuff like that, you need to be abstract enough to be able to plug in whatever people want. You give them an interface, you tell them, do whatever implementation you want, give it to me, and then I can give whatever information you request back. And the real problem on this one was how much load I can take when people start doing crazy stuff. So if they start trying to spawn processes and things like that within their customizations, how do I deal with that? And then I had to do some tricks with basically parsing what kind of references they have when they give me the customization and block some of those references. And then after I did that, it failed again because people can just remove the references and do them dynamically with IL code within their code. So I had to analyze that freaking code and then try to remove those references from the code itself or block it altogether. So it's not as easy as it sounds when you want to give the ability to people to give you plugins to do something, right? So then we came to the actual real load. I did some load tests and I realized that I'm not meeting my goals. I wanted to be able to run in medium instances or small instances on Windows Azure and basically go to the peak without really having any choke points or any breaking points within the application. That was not easy because there was code that was trying to generate all the XML that Twilio needs and all those things. So I realized that I have to do something to optimize for all those things. And that worked better. And then in the end, I decided that I have to refactor again to be able to cope with other scenarios. And one of the freaking scenarios that I haven't finished, and the reason I haven't shipped yet, is build. And I will get to building, which is the most annoying part. Now, currently, the application scales really, really well, but I'm not sure if I'm going to refactor anything again, but I think there is a big chance that that will happen. So the real problems with VoxVoi is I have to do things real time. We're talking about voice, we're talking about incoming calls. I have to be real time. There is no way for me to have delays. Delays means people might hang up, and basically telephony cannot have delays. If you're delaying more than a specific amount of time, there are a lot of things that can go wrong. The most simple one, customer hangs up. He feels that something went wrong. After 2 or 3 seconds, he doesn't get any busy tone, he doesn't get anything, he hangs up. You lost it. Another thing is that if you take a lot of time and the customer is there, their internal systems, because every major provider right now is using some kind of voice over IP abstraction to do external calls or even sometimes internal calls, it might be that the SIP itself, the protocol, times up because I don't give any reply. They think that something went wrong and then they try again. And then the customer thinks that something is wrong, they hang up again. So eventually I have to be real time and I have to optimize for latency. So I have to be as fast as possible and I have to be as accurate as possible, which those things, they don't go together usually. And it's not easy. What I don't care is that if I go down after I initiate the call, so basically after I get the call from Twilio which says I want to do that, and I say okay, you can do it like this, and the call starts, then I don't care if I momentarily go down or if I have a delay on the replies, because basically all the stuff now, all the things that they're needed to happen, they're already running on Twilio. I already gave them the information of what to do with the call, so everything runs there. I don't care. So I left billing intentionally out of it because it's the most freaking annoying part that you will ever come to deal when you're dealing with startups. It's easy to think about the business model. It's even easier to actually code it and then realize that it doesn't work because you've done something either wrong or you forgot about some scenarios. And when we're talking about telephony and the charge is per minute and you have a lot of customers, then mistakes are not allowed because money sum up really fast, and when you're a startup, you can go bankrupt like that just from 20 different calls that last for an hour, right? Because they cost a lot of money. For example, they're calling mobile phones, external connections to 100 mobile phones each, 100 mobile phones, 20 customers for an hour. Do the math, right? There is a lot of money that you can just throw out of the window like that. So you need a way to control all those things. So charging itself is the easy part, because everybody, when we're talking about billing, they think, yeah, whatever, you're going to use a payment gateway, and you're going to have your subscriptions there, and you're going to do charging with that, or you can use Chargify or whatever, and I can use Ogon to do my own custom implementation or whatever. Yes, that's when after you collect the information that you have to bill, right? Finding out the information that you have to bill is the difficult part. It's not after you find it, it's how you find it. So, solution for real-time latency. Currently we're running in Europe, so the main implementation is in Europe. And Twilio servers are close by Amazon, so they're running at Amazon, and their servers are pretty close by. Whenever there is an Amazon data center close to a Microsoft data center, because we're talking about Windows Azure, that's the data center we're running, because we want the best possible latency with Twilio itself. To improve latency, every single menu that you create and every single reply that we give back to Twilio, after the first time, we cache it. So we really have a big cache in-memory cluster. So we're running cache, and we're also running in-memory DB. Do you know Redis? Anyone knows Redis? Okay. So we're running an in-memory DB. Basically means that everything is in memory for us. We, of course, persist information from Redis, but we do it in a, let's say, in a slightly different way than the actual implementation of Redis itself. So if we don't have to query external sources, internally, it takes about 6 milliseconds to create all the reply, find whatever we need, and give a reply back to Twilio. That's how much time it takes for me, right? It doesn't include how long it takes from Twilio to come to me and how long it takes for me to go back to Twilio. That's another thing. I don't care about that, because that is handled by the fact that I'm close to their data center. Now, problem with billing. And yeah, so the problem is that you only know how much it costed after the call is done. So you don't know how much it will cost, because you don't know how long it will last, which is a unique problem when it comes to any kind of per minute charging, right? If we're talking about whatever other kind of application, if you're buying Office 365, yeah, it's gonna cost you $5 per month, and then you know how much bandwidth you can use. You don't care how much bandwidth you can use because it's unlimited, right? But Microsoft knows that it will cost you $5, so they know that it's going to be $5, the amount of money. I know the amount of money that I will have to get from you for the numbers that you use and from the agents you have. Anything else, per minute charging, has to be calculated. And of course, that calculation is being done by Twilio, but it's only being done after the call is done. They have real-time information. They call them usage API notifications. So basically, through their usage API, I have specific trigger callbacks. So when something goes bad, I get callbacks from them, and they say, this guy is running out of money. But that only works for accounts. If and an account in Twilio means that you open an account in your name and you just make me a connected application. So basically, as you do with Facebook, you say this game can access my information. It's the same concept. You basically tell to Twilio that that guy can use that token and access my account, and I can do whatever I have to do. That's the easy way, because if it's your own connected account, I don't care. I use the usage API. I get the callbacks from you, from your own account. You manage your own money. I don't care. You only pay the subscription stuff to me, which is the number and the agents, and that's it, right? That's the easy part. But if I actually have to do, basically do charging to you, so I get charged by Twilio and then I do a charge to you, and I deduct the difference, then I have to calculate all that information. And this is not easy because there are a couple of risks that they come into the equation. And one is that it could be that you use the whole thing and you don't pay in the end. I have your billing information, but you might not have enough credit. Or it might be that you're actually doing a scam. So you're using a cloned visa that is probably not blacklisted yet, and then you do the charges, you do spam through phone, and I try to charge anything I can do about scams. They already tricked my merchant gateway anyway, which is the guys who do the scam checking and the fraud checking, and I got charged and there is nothing I can do about it. So chargebacks is another problem. Some people have a very bad habit of doing chargebacks because they think, for example, you don't provide good service or whatever. It's very important to have agreements. So when people sign up to your service, have agreements that they cover you from those things, and specifically chargebacks. Because they can use the service, then in the end of the month they get the bill, you think you got the money, actually you did get the money, and then they do a chargeback. They say, no, I never approved that transaction. They can do it. You can do it actually as well. And then what happens? After 15, 20 days, I get charged by my merchant, my gateway, merchant gateway, and they charge me $40 just to process the chargeback. And then on top of that, I lose the money of the total chargeback. And then I have to prove that those guys actually allowed the transaction and try to get the money back. And it's a process that you really don't want to get into, right? So those are risks that you have in there. The last thing to consider, which is not a risk per se, but it's something that you have to consider, is that invoicing is not really an option at the beginning. Invoicing means that you let them run, and then they pay at the end of the month. When it comes to those things, I prefer to take the easy way, which is give me your credit card and enable auto top-up, right? And then just set a limit. I give them the possibility to set a limit, and they say, okay, charge me up to $200. After that, stop charging, drop the service. It's easier than getting an invoice in the end and then people refusing to pay the invoice or saying I don't have to pay the invoice or I cannot pay the invoice. Of course, there are exceptions, but that's another thing. So, billing. At the beginning, it was a bit manual. I was checking things with Twilio, then I was going back and doing verifications and all those things, and I had to somehow solve those stuff. And this is something a bit unique, and I do that because I have an experience from underwriting and risk management from the insurance market, and specifically telecommunications as well. So I thought what to expect and what to do. We only enable invoicing for big customers. Obviously, if I come to this company here, or if I go to another big company, they don't work with credit cards. They don't even have credit cards for things like that, right? They only do it in terms of invoicing. You have let's say a security that if you have the contract with them and you go with invoicing, then most likely you will get paid, right? In case you don't get paid, then you have contracts that you can actually, try to get your money and all those things. So we do invoicing, but only for big customers. But invoicing is it sounds weird, but that's a problem. The two things that I already told you that there is nothing you can do about it is scams. They already invaded your payment gateway, so it doesn't matter. You literally cannot do anything. And then it's chargebacks. The only thing you can do about chargebacks is avoid confusion to the customer about what are you charging. So the actual description you give when you're about to charge, make it distinctive enough so they will know what you're actually charging. VoxVoi subscription services, right? It's clear, VoxVoi subscription, they know. That's how much you charge. And if you have to do 2 transactions, VoxVoi subscription, VoxVoi minutes or VoxVoi premium, for example, what you pay on top of your running cost, then do that. So two different charges, one for subscription, one for their actual running telecommunication cost, they know. So after doing the changes and specifically enabling forecasting and pattern analysis, I thought I nailed it. But it was proven that I didn't. Yes, I lost parts. I lost some specific scenarios when I came with pattern analysis, because patterns need reoccurrence, and if you only have 10 calls from somebody, you don't really have a pattern, right? You need more data to do the pattern. So again, you're working on assumptions, and when you're working on assumptions, you might be wrong, and blah 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 blah. All the things I already talked about assumptions, right? So, and this guy here has a very nice slide that says assumptions. Freaking test them. So yes, test them. Now, a visual representation of how it actually looks like, and it's pretty. This is the simple skyline overview, right? There are more components in there that they do things. We're running on Windows Azure websites the public site. So the public site, it runs there, and the dashboard runs there. And there is a connection between the web roles and the big cache, between all the worker roles, and also on the worker roles we have the web roles, and also on the worker roles we have cache as well. What happens with the cache, I will briefly explain it after that and why we have it there. And Redis is running here. There is also other stuff running here. For example, some languages for text-to-speech, they're not supported out of the box from Twilio. I come from Greece. I wanted to support Greek because I want to sell the product in Greece. Text-to-speech from Twilio for Greek language, not really. So I needed to find a way to support the language. So the actual implementation is that we have a service running here, which runs the TTS engine, the text-to-speech engine. People write whatever text they want here, and if it's in a language that it's not supported by Twilio, then I'm passing that information to the text-to-speech engine. It returns an MP3 to me. Then I take that MP3 and I create an equal play verb for Twilio. So instead of using a verb that does the conversion of Twilio, I do the conversion beforehand, and I have that version cast and running for that customer. So that's the way we support more languages. Also, when we're doing the advanced speech recognition, and specifically when we do transcriptions, so when we get a recording and we try to make the text out of it, so to be able to convert it to text, it runs here as well. So it's asynchronous. We just take the recording, we pass it to the system, we say, give us the text back, and when it has the text, it gives the text back to me. And then I can continue with whatever it is. Usually it's just sending an email with the recording attached and the transcription to them, and then persisting the transcription in the database. This part here uses storage, and we use blob for the MP3s that they're not cast, and we also use it to persist the MP3, so we don't have to generate them all the time unless they're actually changed. And we also use it for to persist information that has to do about the users that we have in the system. So basically the credential authentication and all those things. And we also store information that has to do about history and things that really don't have to be real time, and people can wait 1 or 2 or 3 seconds until the whole history comes up and things like that. There is also I have 2 different scenarios that they explain how the flow looks like when when we have an inbound call. I didn't do one for an outbound call because the outbound call is pretty straightforward. But the inbound call without the dynamic ACR it's advanced call routing. If it's not dynamic, so if we're not really querying any data, basically what happens is that somebody calls a number. That number basically rings to Twilio. Twilio knows where to call me, and it says call that URL. Then after calling that URL, what I'm actually information from that guy. Then I'm checking the cache. First step, if it's not there, I'm checking Redis. If it's not there, then I'm actually checking storage. This is really fast. This is the slow part. That's why I don't want that. I don't like that. It's slow. If it's cast, then I'm returning Twiml. Twiml is the language that Twilio understands. And this is abstract enough, so it doesn't matter if it's Twilio or another provider. In this case, I only have Twilio right now, so that's why it doesn't be Twilio. But if it was another provider, then it will be its own language. And then we start building. And this is all the problems that I already talked about. There are 2 ways. One is that if it's the connected account, then we use the usage API. If it's not, then we start doing forecasting. And one of the parameters is what is the destination number and the price per minute. We already know that information from Twilio. So what is the number? We know the number. And what is also the price per minute? We also know that. So we start doing forecasting. And it might sound funny, and you say, why don't you build them when it's an inbound call? Because Twilio builds inbound calls as well. It costs 0.01 cents per minute. So if there is an inbound call, it costs you 0.01 cents per minute. So I need to know that. I need to calculate it for my application, and I need to do the forecasting to find out how much it will cost in the end. After that, when the call is done, Twilio calls me back and it says, I'm done, what should I do now? Then basically, after that point, we casted Twiml. So if it wasn't on the cache and we generated Twiml, that's the point we cast it, because only then we know it's valid. Because it might be that you generated invalid Twiml and you cast an invalid version. And then the next call, basically you take the cast version, it's still invalid, and you lose the customer, right? We want to be sure that the Twiml we generated is valid, and that only happens after the call is done, because we know that everything went well and the call is done. So we cast Twiml after that, and then we get the final price from Twilio. At that point, we know how much it costed. We take the forecasted version, we take the version from Twilio, we do the subtraction, we know how much it actually we have to charge the customer. All those things are event-based. So there are events pretty much everywhere. They're deep diving a bit more on event-based architecture. That's why I didn't have any slides on all those things. You will understand what we mean by the event-driven architecture and all those things. Now, in case we have dynamic ACR, the first part is the same. The second part is the one that is slightly different. So to generate Twiml, we dynamically query the web services, then we parse the result, and if the result is something meaningful to us based on what you said, then we generate Twiml. We still don't cast it, right? We cast it after we're done. Billing starts again, it's the same idea, then we cast Twiml only if the customer said it can be cast, because if it's completely dynamic, there is no point for me to cast it anyway. You specifically say if we have to cast the information. You might have to consider that as well in your own applications, because casting is not something that will magically solve all your problems with latency and whatever. You might be over-casting stuff, which is equally worse as not casting stuff, right? And the biggest problem here is casting a wrong version that it's invalid. And it's pretty annoying if somebody, for example, buys a subscription, he was not a gold member, then he buys a subscription, he's a gold member, he calls back to get the gold services, and the system says, no, you're not a gold member yet, because you cast the wrong version. So, keep that in mind. And I don't know if you have any questions specific or whatever. I was pretty abstract, but yeah. And the website is running on reserved mode, so we also have a small instance running there. And there is also the part where, it's not visible here, but we also have the part where we do all the backups. So Redis is persisting on another VM, and that VM is running here, but that's just a single instance, and then we take backup of that as well. So it's not too much, but it's not little as well.
When you use caching and also your Redis is in memory, is a small instance enough? Do you have enough RAM to cover your needs?
So workloads, the ones that they do the caching, they're dedicated for caching. So that's why I said there is another part here that's not visible where we do the processing of the product of text to speech and the advanced speech recognition. But the workloads, they're running on medium. So it's more than enough. I'm going to scale it down because it never. I was running literally yesterday load tests on it to see how much it will take, and it's more than enough. I don't need it. I don't need 7 gigs of cache.
Your refactoring, did you do it before you went online?
Before going live, you mean?
Before going live?
Yes.
Okay, because I think if you now have to change stuff, this will probably be extremely difficult because you can't have any downtime.
Actually, the architecture is in a way that I can do it very easily because everything is based on service-oriented architecture. So internally, everything for me it's a service. Basically, it's not really a URL that it's listening to a service. I treat components for managed accessibility framework for MEF as services as well. So whatever part I want to change, I basically just change the plugin, and then I don't really bring the service down. I just trigger a rehash on MEF, and then MEF just reads the new version again, and I'm done. Basically, I'm destroying the application domain and I'm just bringing it back up, and it finds all the new references and all the new stuff that it needs. So effectively, there isn't any downtime because at the moment this dies, or even if something happens, it will fail over to the other one. And
I was thinking about data structure changing actually.
Again, there isn't downtime there because it's just in memory. So the structure is by me, and it's just XML. And sorry,
it's schemaless. So
yeah. So I pretty much don't care.
Basically, version the messages. I imagine.
No.
Typically, no.
We don't, because if the value is not there, it's just null for me. So it just doesn't matter.
Right.
I don't parse it.
So you basically design your data structure to always be backwards compatible.
Yeah. We don't. I specifically don't care about values being null because I treat it in the code that they're not there anyway.
Mm-hmm.
So if they're there, they're used. If they're not there, then they're not used. So because the actual, and that's a thing that it's a bit weird, but in the implementation of when it comes to telephony, it's not easy to decouple it completely. The actual services, they have a tight coupling with the schema. So if the service is updated, it always knows what schema to expect. So it doesn't care. And if you're hitting when there is an inbound call, if only this part is upgraded and the other one is not, this is still running the old plugin, so it will treat the old schema. This is running the new plugin, so it will treat the new schema. And it doesn't affect it in anything. So it's, yes?
Before asking other questions, this is the last one, I think. What about staging environments? You have like for environments, some of which are local and some of which are online.
Locally, it's only the compute emulator that it's being given by Windows Azure to do. But actually, production and staging is exactly the same for me. So internally, it's just there is an internal flag that says some applications that relate to accounts for me, they're staging. So they're hitting different kind of code instead of that one. So it happens here. That guy here knows what to do in terms of what to call and where. If it's specific applications that the application ID says that this is staging, then it's hitting different data instead of the other. So there isn't really a staging environment. It's exactly the same. Weird, right? But yeah. Yes.
I have a question. What about, did you find any trade-off between optimizing and scaling horizontal? Like, when would you choose to optimize your code further? And when would you choose to don't spend the time on making your code maybe more complex or something, and just scaling horizontally?
Complexity doesn't really affect scaling, right? So it's not really that the more complex it is, it will not scale or not. I think what you, correct me if I'm wrong, right? I think what you're trying to ask is how do I choose how much time I will spend on making something complex enough to support something, or just make it work and then go on with something else? No?
Maybe, yeah.
Or if you find a way to calculate that, let us know. So there is in a way. The way you choose what to do and what not to do is customer related. You might think as much as you want that this is going to be the best feature ever, and then you look at your statistics and nobody uses that. So it's that's always the risk with the startups. If you know the market well enough, then you can make assumptions, more correct assumptions if you like. If you don't know the market well enough, or even if you do, it's so dynamic and so abstract that you cannot really do any predictions. You're talking about global market here. I don't know what the Chinese guys want, or I have no idea, or Brazilian guys. But it's cool for them. Might be that they press a button and a girl starts singing samba or whatever. So it's I don't know that. So there isn't a way to know that, unfortunately. It's trial and error. There is no other way. And then you might read a lot of articles that says, this and entrepreneurs know by heart that what they will do and all those things. Bullshit. You don't. It's customer related, and when it comes to customers, you just go with it. Now, complexity itself, it doesn't affect how you scale. Even if you have interdependencies, or even if you have complex components that rely on other stuff or whatever, the simple rule of thumb is as long as you do that in a memory optimized way and in a stateless way, you should not be that much affected. So you should be able to scale well enough. But then again, that's an assumption. And the only way to test the assumption is test it.
Well, my question was more along the lines of, let's say that you can choose either to optimize your code further, or choose to, because basically your statistics are saying that you're losing customers, you're dropping calls, and you guess that it's the performance of the application that's to blame, right? So you can choose to spend time on optimizing your code further, or maybe, I don't know, work on maybe distributing the load more between instances. I guess that's like a balanced exercise as well.
Depends the failure rate, depends how much calls you lose, depends on the reason you lose the calls, depends on a lot of things. If the reason you're losing calls is because you're dropping HTTP requests that they're coming from Twilio, obviously something is wrong, right? And you have to optimize, otherwise you're unusable basically. If you're dropping calls, in my case, if I'm dropping calls because I cannot accept them, it's a failure. And it's like critical failure for me. I cannot drop calls. I should not drop calls.
How do you decide to optimize your code further or go, I don't know?
If I'm dropping calls, because of performance or for whatever reason, if the rate of dropped calls is more than a specific amount, depending on how much calls you have, you halt everything and you start investigating why. You're losing customers at that point.
Yeah.
So there is, I think, if you get to the point that you have to think about those things, then you're not alone, right? You're successful. You have other people with you, at least one or two, that then you can just go back to the drawing board and start thinking about those things. So it's, yeah, you don't get rich in the next day, unfortunately.
Thanks.